Hello, class 7. Today we will talk about elements, compounds and mixtures, okay? So in the last class we did the whole chapter about matter and its properties. So let us revise what matter is, okay? Matter is anything that has mass and occupies space, and there are three states of matter: solid, liquid and gas. Now here we will not be talking about the solid, liquid and the gas. We will talk about another aspect of matter, and that is matter can be classified into pure and impure substance, okay? Now what is a pure substance? A pure substance are those which have uniform composition and properties, okay? So anything which has uniform composition and properties are called pure substances. And broadly we can say that pure substances are of two types: elements and compounds, okay? Now, what is an element? There are two types of pure substances: element and compound. Now, an element is a pure substance made up of one kind of atoms which cannot be divided any further by any chemical physical means. So what is an element? An element is a pure substance which cannot be broken down any further. And there are four types of elements. We have already studied 1, 2, 3 and 4. The first one is the metal. The second one, non-metal, metalloids, and the last one is inert gases. So when we talk about the elements, elements is a pure substance. Element is a pure substance made up of only one kind of atoms, and which cannot be broken down any further, and it is classified into metals, non-metals, metalloids and inert gases. Now, we very well know what are metals, we very well know what are non-metals, metalloids and inert gases. Metals are those elements which conduct electricity and heat very well. They are hard substances like sodium, magnesium, iron, gold, silver, copper, zinc, manganese, magnesium, so on and so forth. Non-metals: phosphorus, sulfur, chlorine, oxygen, nitrogen and so on. Metalloids: antimony. There are many metalloids like boron, silicon, germanium, arsenic, antimony, tellurium and polonium. Next, inert gases: helium, neon, argon, krypton, xenon and radon. So we talked about the elements. Elements, once more I will tell you, are those pure substances which cannot be broken down into any more simpler substances and is made up of only one kind of atoms. Now we come to compounds. Now what is a compound? A compound is a pure substance made up of two or more elements combined together in a fixed proportion. So a compound is a pure substance made up of two or more elements combined together in a fixed proportion. Now, when we talk about compounds, we have to know about their characteristic properties. So we will directly go to the characteristic properties of the compounds. Number 1, compound is made up of two or more elements. For example, water, H2O. Water is made up of two elements: hydrogen and oxygen. Similarly, there are other compounds like sulfuric acid. H2SO4 made up of hydrogen, all the non-metals, hydrogen, sulfur and oxygen. The common salt made up of sodium and chlorine. Sodium chloride, NaCl, a metal and a non-metal. So, the property number 2, a compound is always made up of same elements combined in a fixed proportion. So, when we talk about, what does that mean? When we talk about water, when we learn about water, water, as you know, is made up of hydrogen and oxygen. It is always made up of 2 atoms of hydrogen and 1 atom of oxygen. It's always made up of. Any where you go, sulfuric acid is made up of hydrogen, sulfur and oxygen. Similarly, when we talk about the next compound, that is sodium chloride, is made up of 2 elements, always sodium and chlorine. When we talk about rust, rust is iron oxide, Fe2O3, 0.23 H2O. But this 23 over here depends upon the rust. So it is not a constant figure here, 23. Instead we can say it is XH2O, means X is variable. We do not know precisely, we cannot say precisely how many number of water molecules are present, water of crystallization is present in the rust. So anyway, the rust is always, wherever you go, rust is always made up of iron and oxygen. Now, the point number 3, the characteristic number 3 is compound is always homogeneous, means homo means same. So it is made up of the same kind of elements. They have the same type of composition and same type of property. Why? Because it's a pure substance. So I already told you about a pure substance. A pure substance are those substances which have the fixed properties and composition. So similarly, compound is a pure substance, so therefore it will have the identical composition and the same property throughout. The composition will be same. Point number 4, the properties of compound is different from those of constituent elements. Now what does that mean? The properties of compounds will be totally different from its elements that is made up of. For example, sodium chloride. When we talk about sodium chloride, common salt, it is made up of sodium metal, highly reactive metal, and chlorine, a greenish yellow gas, non-metal. Now let us talk about the properties of sodium. Sodium is a highly reactive metal. It will react with the air, it will react with the water, it will react with your skin. Chlorine is a highly poisonous gas, greenish yellow poisonous gas. But when these two combine to form sodium chloride, a totally new substance with a totally new properties and composition will be formed. So the compound will totally differ from its constituents element. Sodium chloride is white crystalline. It's totally different from sodium, or it is totally different from its another constituent element, that is chlorine. Similarly, when we talk about water, another compound, a simple compound that we use every day, it is made up of hydrogen, a gas, the lightest gas, and it is made up of oxygen. It is made up of a hydrogen and it is made up of oxygen. Both are gases. So when the hydrogen and the oxygen both combine together, it forms a totally new substance, that is water, which is a liquid. So the properties of the different elements that makes up water will be totally different from the water which has been formed. Is it okay? So therefore, that's what it means by the properties of compounds differ totally from those of the constituent elements. And we cannot, point number 5, we cannot separate the constituent of mixture by any physical means. We can do it chemically, but not easily separate sodium and chlorine from sodium chloride. We cannot separate hydrogen and oxygen from water by simple physical means. Yes, we can do it chemically. That is called electrolysis. When water is formed, if we pass direct electric current through direct electric current in a special apparatus, and the process is called electrolysis. Now water will break up into hydrogen and oxygen gas. So we can do it chemically, but not by any physical means. So when a compound is formed, energy is usually given off, or it is absorbed. So when there is a formation of a compound, obviously it's a chemical reaction, and there are two types of chemical reaction that we have already done earlier when we studied the chapter of physical and chemical changes. The two types of chemical reactions, that is exothermic and endothermic. Exothermic reactions are those in which heat is given off, and the endothermic reaction is the one in which heat is absorbed. So when a compound is formed, there is always change in the energy. Energy is either given off or taken in. Now these were the properties of compounds. Like once more we'll repeat it. A compound is made up of two or more elements. Number two, a compound is always made up of the same elements combined in a fixed proportion. So when we talk about the fixed proportion here, I forgot to tell you, like for example, water. Again, very simple, very important, very commonly found compound, that is water. When we talk about water, it is made up of two atoms of hydrogen and one, and H2 means H2O means one molecule of water. In that one molecule of water, it is always made up of two atoms of hydrogen and one atom of oxygen. Suppose if there is a compound which is made up of two atoms of oxygen, then this is not water. This is a totally new compound, that is hydrogen peroxide. It is hydrogen peroxide. The elements are the same: hydrogen, hydrogen, oxygen, oxygen. But it is made up of two atoms of hydrogen in both the cases. But the number of atoms of oxygen differs here. In water, only one atom of oxygen is present, and a molecule of hydrogen peroxide is made up of two atoms of oxygen. So all the compounds will have are made up of elements in a fixed, simple ratio. Point number three, a compound is always homogeneous. That means the properties and the composition will be the same. The properties of a compound differ from those of the constituent elements. And the point number five, it is not possible to separate the constituents of a compound by simple physical means, and when a compound is formed, energy is usually absorbed or energy is usually taken in. Now we deal with mixtures. Now we come to the mixtures. Now, what is a mixture? A mixture is an impure substance made up of elements or compounds or both mixed together in any proportion. It does not have a fixed proportion. That is why a mixture is an impure substance. Elements and compounds are pure substances, whereas mixture is an impure substance. Why? Because mixture does not have a fixed composition. So, examples of mixtures: muddy water. You must have heard about. You must have seen muddy water, milk, honey, blood, urine, and air, and so on. These are all mixtures. Okay. Now, before we talk about after the example of some of the mixtures, we will talk about the properties of mixtures. Now, what are the properties of mixtures? In the mixtures, the constituents of the mixtures are not in a fixed proportion. They are not in a fixed ratio. Any amount of both the substances, or three substances or more substances, can be mixed together. So when we make mortar, we mix water, lime, sand and cement. And the proportion of each of these will differ from person to person. So it is the mixture. In mixtures, the constituent is not in a fixed proportion. A mixture do not have any specific property of its own. And the constituents of mixture will exhibit its original properties. For example, we have the mixture of water and salt or sugar. No new substance is formed in this case. The components of the mixture will retain its original properties, like water remains as water, and the mixture of salt and water, salt will remain as salt, because the taste will also remain the same, and we can get the constituents back by simple physical means. By when you heat water, you heat the mixture of the salt solution, water evaporates, we can get back water, and what is left behind? The salt. That means you can get back the constituents of the mixture easily by any physical process. And the constituent of the mixtures will retain their original properties. A mixture does not have fixed melting or boiling points. Like, for example, if you put in a cup of water, you put 1 tablespoonful of salt. Again, we have a mixture. 1 spoon of salt, and over here you put 2 spoons or maybe 3 spoons of salt. 3 spoons of salt. The boiling point of the mixture having 1 spoon of salt will be different from the mixture of water and salt having 3 spoonful of salt. So the properties of mixture are not the same anyway. Okay, so the formation of a mixture does not involve any energy. So no energy is lost or no energy is gained. No energy loss or gain takes place during the formation of a mixture. The constituent of mixture can be separated. As I already told you, we can always separate the mixture of salt and sand easily by heating it. Water evaporates, leaving behind the salt. So we can separate the constituents of mixture by simple physical means. In this case, the separating water and salt, we use the process called, a physical process called evaporation. Now, when we talk about mixtures, we want to know that what type of mixtures are there. There are 2 types of mixtures. One is homogeneous mixture and the other is heterogeneous mixture. Homo means same. So a mixture in which the constituents are uniformly mixed throughout is called a homogeneous mixture, whereas a mixture is said to be heterogeneous if the constituents of mixture are not uniformly mixed throughout. So this is called the homogeneous mixture and a heterogeneous mixture. For example, we have a glass of water, and again we put salt in it. We have a glass of water and we put salt in it, and then stir a little, and then we divide it into 3 parts. Part 1, part 2 and part 3. Will it taste the same? Portion 1, portion 2 and portion 3, if we stir it properly, obviously it will taste the same. Why? Because it is a homogeneous mixture. It's a homogeneous mixture. You can try it at home by adding sugar in the glass of water and stir it properly. So all the parts of the sugar solution will taste the same. It's equally sweet. Why? Because this type of a mixture is called a homogeneous mixture. A mixture in which the constituents are uniformly mixed. This is not the only example of homogeneous mixture. We have brass. It's a mixture of copper and zinc. Another homogeneous mixture is bronze. It is made up of copper, zinc and tin. We have heard about stainless steel. Stainless steel is not a metal, it is a mixture. It's an alloy, we call it. It is made up of iron, nickel, chromium and carbon. So brass, bronze, steel, they are mixtures, and these mixtures of different metals are called alloys. Anyway, so we'll go to the next Example of a mixture, that is heterogeneous mixture, a mixture in which the constituent particles are not uniformly mixed together. As I already told you about mortar. When we talk about mortar, the amount of lime, it's the amount of cement and the sand and the water, it depends upon person to person. So we can have a mixture of iron filings and sulfur. We cannot, that is also a homogeneous mixture. Muddy water is a very good example of heterogeneous mixture. So differences between homogeneous mixture and heterogeneous mixture is given on page number 24. You can have a look. A heterogeneous mixture is the one in which the constituents are uniformly mixed, whereas a heterogeneous mixture is the one in which the constituents are not uniformly mixed. So homogeneous mixture, the constituents are uniformly mixed, and heterogeneous mixture, the constituent particles are not uniformly mixed. Homogeneous mixture has the same property throughout, whereas we do not have the same property in heterogeneous mixture. And the last point of difference is the constituents of homogeneous mixture cannot be easily separated, whereas the constituent particles of heterogeneous mixture is easily separable. They can be separated easily. So we have dealt with the elements, the compounds, and the mixtures. In the next class, we will talk about the separation of mixtures. Okay? We will talk about the separation of mixtures. So thank you for today. Thank you for watching. I hope you understood well the concept of elements, compounds, and mixtures. Thank you. See you again in the next class.